In this video, we'll be doing the question you see on the screen from the 2023 Leaving Cert Higher Level Maths Paper 1. If you're looking for a different question from this paper, there should be a playlist in the description below. And if you're looking for a different paper entirely, have a look on my channel. I'll be doing all of this on a whiteboard, hopefully just like you're used to your teacher doing. But remember, we are on YouTube, so take advantage of that. Pause, try the question first, and even change the speed of the video to half speed or 2x speed if that's your thing. If you find this video or any of my videos useful, I would greatly appreciate a like, a subscribe, or especially sharing it with someone else you think might help. It might help. The question we're asked to solve has an absolute value in it, and they become a little complicated. Nothing too bad. We can solve it just using numbers, but I'd always like to draw a picture when I can. It's the teacher in me. So instead of drawing this, I'm going to first of all draw 5 plus 3m. Or more exactly, y equals 5 plus 3m. We'll put that in an my graph. That's one little different thing here. Instead of imagine m is just x. It comes out as the same thing. So how do we draw this? The y-intercept, if m is 0, y equals 5. So we put that here somewhere. And the slope's what multiplying the x, or in this case the m, is 3. So it goes up, let's put this in as a dotted line. It goes up like this. And it would usually go down here. This line would. Now what's different about the absolute value is, the absolute value doesn't let anything become a minus. It doesn't like it. If it's a minus, it makes it a plus. So, for example, like this number here is 5. Its absolute value is fine at 5. So if m is 0, this is 5, it leaves it alone. At 6, it leaves it alone. At 7, all up here, it leaves it alone. Down here, all the way down to 0. Let's put this in as a solid line now. 0, it's even okay at 0. It says, okay, you're not a minus, I'm going to leave you alone. But when we get down here, when we get to say a minus 1, it says, I don't like that, I'm turning you into a plus 1. At minus 5, I don't like that, I'm turning you into a plus 5, and so on. What that looks like is we bounce off the line like this. We get the mirror image of it as it folds up through. That's what the absolute value here looks like. And on the other side, I can draw 11, or y equals 11. Let's say this is 11 up here. That just looks like a straight line. So the answer to this question is going to be these 2 points here. There's two answers, or more exactly the m, where they meet down here. So we're going to get two answers for that. So we can do this a couple of different ways. I'll show you both ways. The first way is, I like to think of just the line. So let's find this point here first of all. Let's imagine this line, which was here, and this line 11, which was here. And we solved that just by ignoring the absolute value. That just looks like 5 plus 3m equals 11. And we solved that. That gets 3m is equal 6, m is equal to 2. So that number here is 2. That's what m would equal on that side. Quite similar on the other side. Let's imagine what this line is here. Now remember, if I continue this on down this way, it would hit here at minus 5. Because it's the opposite of this one. This would hit a plus 5. The slope of this slope was 3. This slope would be minus 3. So this line here would actually just look like minus 5, the y-intercept, minus 3, the slope, times m. And when does that hit 11? Well, that hits 11 when we solve this equation. So if we just solve that, we get minus 3m is equal to 16. M is equal to minus 16 over 3, which is what, 5.33, or minus, 5. So this was minus 5.33, or leave it as a minus 16 over 3. That's the two answers. You don't have to draw a picture of this every time. It's much simpler than that. You could just assume that this is a positive number, like I've done here. Assume it's a positive number and solve it. You'll get one answer. But then you can say, I can't really assume without taking the other side. So assume what's in here is a negative number. And that's all I've done here. I've just made it multiplied by a minus. Assumed it was in a negative number and solve it again. And you get this answer. That's how you can do this straight from the beginning. That's all you need to do. No picture, but I like drawing pictures. Part B is quite straightforward. They give us this equation here and they simply ask us to express k in terms of h and j. Basically they want k on its own. K equals and just one k, because that's the big problem here. There's two k's here. And even more difficultly, one of them's on the bottom row mixed up with the j. So we're going to have to do a bit of work here. First thing I like to do is just get rid of these bottom rows if you can. Multiply them both across. So this j plus k will multiply by 1 and get j plus k. This h will multiply by the k and get hk. Bit more manageable now. Still the k's are separated. We want them together. Let's get them all together on one side. Let's move them all on the left. We'd leave this k alone and this one will become a minus hk. This j, let's get rid of him. We don't want anything on the left with the k. Let's get over this side, minus j. Now we can combine these k's at this point. K goes into both of these terms. So take it out. K goes into this one time. K goes into this minus h times. Equals minus j. And the final answer would be k is equal to minus j over 1 minus h. Just checking my answer. Oh yeah, my answer is slightly different because you could also leave this as divide everything by a minus or multiply everything by a minus. That could become j over h minus 1. H by a minus, minus h by a minus is plus h, 1 by a minus 1. Both of these are perfectly okay answers. In part C, they tell us this expression here is a factor of this expression here. And find the missing letters. So there's a missing number, sorry. There's a P here and an OR here. So knowing that this is a factor of that, we can solve, but we can find those letters. So how do we do that? There's a couple of ways. One of my favorite ways, whenever I have a chance to divide algebraic expressions, I like doing it. So this might not be the way you like. I'll show you it, skip ahead a few minutes and I'll show you a different way. Then, and I'll show you how they're very similar. So dividing, we divide this into this. Now you have to be a little careful about that. X squared minus px plus 1. And the thing we need to be careful about is, I like to be careful that we have all the x terms. For example, we have an x squared, an x, and a no x. It's fine on this side. But we're something missing here. We have an x cubed. We've no x squared. So I like to just put in an x squared. You can work around it, but it's very easy to make a mistake if you don't put in the 0x squared. Minus 2x minus 3r. Okay, so how do we divide in? We basically just take the biggest number of both. So what would we need to multiply x squared by to get x cubed? And the answer is just an x. And then once we know that, let's multiply the x by everything here and see if it fits. So x by this is x cubed, x by minus px is minus px squared, x by 1 is just a plus x. They don't quite fit, but let's take them away and see what we're left with, what remainder we have. This away from that is nothing. 0 minus p, that would become px squared. And minus 2x, take away another x, would be minus 3x. And then let's take down the next term. 3r. This is just a long division, really. Okay, let's see how many times this goes into this. And here's the interesting thing to remember. It's a factor. We know it goes in perfectly. This goes into this perfectly. So what do we need to multiply this by to get this? Just p plus p. P times x squared will get px squared. P times minus px will get minus p squared x. And p times 1 will get p. Now here's the thing. This goes in perfectly. These are meant to equal. This minus this is meant to equal 0. That does work. Minus 3 minus p squared, so plus p squared, should equal 0. So for now, let me just write it as x there. And then minus 3 or minus plus p should again equal 0. So we just know this term and this term have to be 0, so we can solve that. For example, let's do it here, and I'll leave the room for another way over here. For example, this equals 0 would be minus 3 plus p squared equals 0. That'd be p squared is equal to 3. That'd be p is equal to plus or minus square root of 3. But I never mentioned at the start, they did tell us that p is less than 0. So it can't be the plus one. So p must equal minus square root of 3. So we've solved for p, or we'd be left with, let's squeeze it in down here, minus 3 or minus p. But I know what p is. It's minus, two minuses make a plus, square root of 3. That has to equal 0 as well. That'd be minus 3 or is equal minus square root of 3. That'd be or is equal to 2 minuses cancel, square root of 3 over 3. That's the answer. That's perfectly, sorry I had to squeeze it in there. That's the perfectly correct answer. There is another way to do that though. If we know this is a factor of this, that means this guy here, x squared minus px plus 1 multiplied by something must equal this guy here, x cubed. Let's put in the 0 again. 0x squared minus 2x minus 3r. The something here must be, it must have an x to make it x cubed. And then just some number, any letter you want. Let's see, we haven't used a. So use a. And you can multiply these together and just start equating them. So if I multiply this side out, I'll do it quite quickly because we've already done it one way. We'll get x cubed that way. All the x squares, we'll get a minus px squared and an ax squared. So we'll get, let's write it like this, x squared. Where will the x squares come from? A minus p we'll get, and we'll get an plus a. Let's see, what about the x's? Where will we get an x? We'll get a times minus px. So that'd be minus AP. Where else? We'll get a 1 from this, plus a 1, and I think that's it. And then the solid numbers would just be 1 times a, plus a. And that equals this side here. But we can start equating things off. For example, a, well, let me write all 3 of them. What's in front of the x squared on the right is 0. What's in front of it here? So a minus p must equal 0. That'd be one thing we know. What's in front of the x here is a 2. What's in front of the x here is this. So with minus AP plus 1 must equal 2. And finally we would get minus 3r must equal a. 3 equations, 3 unknowns. We can solve that. It's not as bad as it looks because the first 2 have a and p. And in fact the first one just says a equals p. So the second one then becomes, let's say we'll put, instead of a, we'll put a p. We'll get minus p squared plus 1 equals 2. Minus p squared equals, I just noticed there should be a minus 2 here. There should be a minus 2. Should be a minus 2. This should become minus 3. P squared is equal to 3. P is equal plus or minus square root of 3. But for the same reason as before, we get minus square root of 3. Saying we fill that in and we can find out what a is. Well, a is the same. Put that in here and we get the same equation as this one here. Again, we'd find or is equal square root of 3 over 3. Okay, there's probably another way to do that as well, but they're the two most common ways. Like I said, for some reason I've just always liked dividing, so I'll do that whenever I get the chance. Alright, thank you for watching. If you have any follow-up questions, let me know in the comments. I'll do my best to answer. Thanks for watching and have a great day.